Hi, everybody. So as we are now trying to solve polynomial equations that are larger than quadratic equations or larger degrees, we're looking at different types of factoring. And we reviewed factoring quadratic equations that were, or things that were in quadratic form in class. And so today we're starting at the bottom of page 15. And we're going to be talking about a new factor pattern called the sum and difference of cubes. Or me being cute, my ice cubes. So the sum and difference of cubes. Now, I am going to show you where this comes from in class, but for now I'm just going to show you the pattern and how it works. In order to review the sum and difference of cubes, I really like to review the cubes that we really are going to need to know for this section. So we should know that 2 cubed means 2 times 2 times 2, so 2 cubed gives me 8. 3 cubed, 3 times 3 times 3 is going to give me 27. 4 cubed, another one. 4 times 4 times 4 gives me 64. 5 cubed, I think a bunch of you might be saying to yourself, 125. And 6 cubed, 216. So now it is important that you know these cubes. It will help making factoring the sum and difference of cubes easier. Okay, so at the bottom of the page, you'll see that there are 2 boxes, and they explain the sum of 2 cubes and the difference of 2 cubes. So this is the sum and difference of cubes. So sum, you can see the cubes are being added, difference, they're being subtracted. The factored form of it is over here. Factored form. So you can see that you take A plus B times, you square A, you change the sign to negative, you multiply A and B, and then you square B. And this difference of cubes is pretty much the same, except it becomes A minus B, and then this term changes to a positive. So noticing that that is the opposite of that, the opposite of the term, and that you're squaring in the trinomial the A squared and the B squared. Now, I know this really means nothing to you until you see it in use, but let's look at an example where we use it. Okay, so first of all, this is the sum of cubes. So x cubed plus y cubed turns into x plus y, x squared minus xy plus y squared. So step 1, so here's our example, x cubed plus 27, or x cubed plus 27. Step 1 is to write all the terms as cubes. All right, well, x cubed is already written as a cube, so I'm going to turn 27 into 3 cubed, okay? Now, I'm going to write just below this in green so you can see it. So this takes on the role of x, and this takes on the role of y for the pattern. So now we're going to substitute the values directly into the pattern. So we would get x plus 3 times. So x squared in this case, minus, you multiply 3 times x and you'll get 3x, and then you square 3, which is going to give me plus 9. So you can see I substituted those values directly into the equation, and now I'm in factored form. Okay, using this sum and difference of cubes. All right, let's try another one. All right, step 1. Now we're looking at the difference of cubes, so I wrote the pattern for us. If you've got x cubed minus y cubed, the factor pattern is x minus y times x squared plus xy plus y squared. Okay, step 1, write all terms as cubes. So I took x cubed was already written as a cube, so I changed 8 to 2 cubed. Now, this takes on the role of x, this takes on the role of y, and we plug it, we substitute the values into the pattern. So we'll get x minus, oops, and I should change this to a minus, sorry. X minus 2, and then it will become x squared plus 2x plus 4. Squaring that y squared, making sure it's 4. Okay, so it is just basically following the pattern, but it can get a little bit trickier. So you may notice in this next example that I have 8 and x is being cubed. So the first thing we still do is we write them as cubes. So the first term I'm going to change to 2x quantity cubed. Because I cubed the 8. So think of 8 as 2 cubed and x cubed. And then using the laws of exponents, I can actually write this as this, kind of moving backwards. All right, minus 1 cubed. 1 cubed is 1. All right, now I use the factor pattern, so it's going to be, and I'm not going to write it down, I'm going to see if you can remember, it's going to become x minus y, so x minus 1, okay, parentheses, then x squared. So remember, this whole quantity is squared, so it would become 4x squared plus, because it changes sign, I multiply the 1 and the 2, and I get 2x. And then I square the y, so in this case 1, so plus y squared. And that is 8x cubed minus 1 in factored form. All right, so I'm going to ask you now to try to do the try now. 125x cubed plus 8. Now, follow all the rules, bring it to class tomorrow, and we will check. All right, so that's one type of factoring we're going to be doing. The next one where we're going to review, and I've actually already introduced this to you, factoring by grouping. We did spend some time factoring by grouping. Now let's remember, to factor by grouping, you need four or more terms. 4 or more terms. Not 2 terms, not 3 terms, 4 or more terms. So I see that I have a polynomial with 4 terms. I want to make sure it's in standard form if I can. And then I look at grouping each set together and pulling out the greatest common factor. So the greatest common factor of the first 2 terms is x squared. I'd be left with x minus 2. And the greatest common factor in the second term is negative 9. Now I want it to be negative 9 because I need the binomial I'm left with to look just like that. So the only way I'll do that is if I take out a negative 9, and I'd be left with x minus 2. So I know I factored this right if these 2 binomials are the same. Now remember, that now becomes our GCF, so we pull it out to the front, and you'll be left with x squared minus 9. Now I always take that first term and I actually put it in parentheses. Now, based on what we did in class, this is not in its lowest form, so we have to factor it completely. So it is the difference of squares, which I'm hoping you see, so it becomes x plus 3 and x minus 3. And there is my polynomial in factored form. Okay, let's keep going. X cubed plus x squared plus x plus 1. I'm going to group the terms together. This one's a little different because when I take out the x squared of the first one, I'm left with x plus 1. And you may be saying to yourself, well, gosh, that's already x plus 1. When that happens, you have to actually factor out a positive 1. So I pull out a 1 because I want a term in front of the parentheses. So then there's the x plus 1. All right, now x plus 1 becomes our GCF. We pull it out to the front. We're left with x squared plus 1. That is not the difference of squares, so it is in its lowest form. I cannot factor that anymore. All right, the factoring by grouping. I want you to try the last example, the negative 2. X cubed minus 4x squared minus 3x minus 6. And we will go over and make sure you did it in class tomorrow. All right, so now where are we going to use all this? Well, we've been graphing polynomials, but they've all been in factored form. So now we're going to have to practice solving to find our x-intercepts. Now, this directions say find the real or imaginary solutions because we can get imaginary solutions to a polynomial. All right, so the first thing that we're always going to want to do is look at our polynomial and write it in standard form. So I'm going to rearrange in descending order by exponent and set it equal to 0. Okay, and then I'm going to take out the GCF because greatest common factors first. So we take out a 2x and I'm left with x to the 4th minus 7x squared plus 12. All right, now you may be seeing that this trinomial is in quadratic form. And so remember, we talked about how x squared times x squared equals x to the fourth. So just treat it like a trinomial, and instead of doing x and x, we're going to do x squared and x squared. We still look at the factors of 12 that add to negative 7, which are going to be negative 5 and negative 2. Ooh, that's 10. Sorry. 4 and 3. I made a mistake there. I was thinking 10 for a second. Okay, so negative 4 and negative 3. So x minus 4 and x minus 3. You can still go through the check doing this for yourself, and you'll get negative 4x squared and negative 3x squared, which does give me that middle term of negative 7x squared. So I factored it properly. Okay, let me get back to that. Now we have to keep going because this one is the difference of squares. So I have to factor that to x plus 2 and x minus 2. And we still have the x squared minus 3. That is not the difference of squares, so we leave it alone. A lot more work now, isn't it? But remember, we're looking at this polynomial. This could have up to 5 solutions. So that's why this is happening. All right, now to solve, we set each factor equal to 0. So x equals 0. Then x plus 2 equals 0. So x equals negative 2. X minus 2 equals 0, so x equals 2. And x squared minus 3 equals 0. Well, I look at that. It is a quadratic equation. I'm going to add the 3 to the other side. And now I'm going to use the square root method. So I take x equals, and when we take the square root of both sides, we don't want to forget that we have a plus or a minus answer. So we have 5 solutions to this polynomial equation, okay? All right, let's try the last one. All right, so we see that it's a polynomial, but in order to solve it, it has to be set equal to 0. So we're going to subtract the 4 to the other side, and we get 0. Now we see it's in quadratic form, so we factor it like a trinomial. So x squared and x squared. And I want the factors of 4 that add to negative 3, which is going to give me 4 and 1. So x minus 4 and x plus 1. Go through your check. Now x squared minus 4 is the difference of squares, so I'm going to keep factoring. Okay, and now I'm going to set each factor equal to 0 and solve. So x plus 2 equals 0. So x equals negative 2. X minus 2 equals 0. So x equals 2. And x squared plus 1 equals 0. So now I subtract 1 on both sides, and I get x squared equals negative 1. Oh, goodness. X squared equals negative 1. I take the square root of both sides, and x is going to be equal to plus or minus I, because the square root of negative 1 is I. Okay, so we have 4 roots, 2 of which, in this case, are imaginary solutions, which means they will not cross the x-axis there. They'll only cross at negative 2 and 2. All right, so that's our lesson for today. Tomorrow we're going to be practicing this, and like I said, we're going to be spending time over the next 2 to 3 days working on this factoring and solving polynomial equations by factoring. Have a great night, guys.